So, good morning. I hope you can hear me, see me, and you can see my PowerPoint. So, the subject code is 20 MLB B308. Very good morning, students. So, the subject name is Advanced Clinical Chemistry. As we know that we are studying all heavy metals in this subject. So, we have only 2 units. First unit are all about the toxicity and poison of heavy metals, and second one is organ markers. Okay, organ system markers, various types of blood markers. So that's it. So far we discussed all basics in these heavy metals, classification of heavy metals, their impact on the environment, their biological effects, then their proper disposal, the importance of biomedical waste, their classification, all these things has been already discussed. Okay, then we have started discussing individual heavy metals. So first we started with aluminum, then we discussed about after aluminum toxicity, then we started discussing about this stibium or antimony's toxicity that is commonly from eyeliners. Then we discussed about in detail about this one arsenic. So arsenic will cause this world's worst dangerous poison. So this is usually used for killing rats, and that can also induce uh, toxic effects on humans. Then we discussed about beryllium. Okay, beryllium is usually used in this transmitters and electroconductors, especially in radio transmitters. Then we discussed about cadmium. Cadmium is used in batteries, right? So it will cause this bone disorders. Then we discussed about chromium. So chromium 3 has some health benefits, and chromium can cause some mediate lung cancers and lung disorders can occur. Then next we discussed about cobalt. So cobalt we discussed recently. So cobalt also has some health benefits. So in the yesterday's class, we discussed about cobalt toxicity in humans. Usually this cobalt is used as a transplant, okay, limb transplant for joint transplant. So the patients who have underwent this cobalt induced joint transplants, they may got some toxic effects. So this is post-transplantation toxic effects can be seen in the patients who has been underwent this limb transplantation that has this cobalt as a metal in their transplant materials. So this is one way you will get exposed to these things. So usually cobalt has health benefits. Okay, so the all meat and vegetables have this cobalt, and cobalt also very important for synthesis of vitamin B12. Okay, so that is why vitamin B12 is called as cobalamin. Okay, so this is all about cobalamin or cobalt. Then we started discussing about the next metal, which is the copper. Okay, so copper. So in today's lecture, I will discuss in detail about the copper and iron toxicity. Okay, so in today's lecture, we will discuss copper and iron toxicity. And also tomorrow I will conduct quiz exam. Okay, surprise test actually, that is quiz for 12 marks. I will conduct that in the LMS, and you need to write the exam. Okay. So coming to the copper toxicity. So what is this copper? What are its toxic effects? Let us see this copper toxicity. So copper will cause this Kaiser Fleischer rings. Okay, it will cause a brown color ring around the eyes. So this is a characteristic feature to identify this copper toxicity. Okay, MCQ or theory. I will conduct only MCQ question exam. Okay, it's just MCQ solely. Don't worry. So tomorrow there will be MCQ test in LMS. Okay. Yeah. Fine. Yeah. So this is all about the copper. So copper will cause this brownish ring around the eyes, and that is a characteristic feature. So copper will cause many problems. Okay. So let us see this copper. So copper is exposed. Copper is very useful for human biology. Copper is a good cofactor for which enhances angiogenesis or formation of new blood vessels. It will be act as a neurohormone and regulates homeostasis of central nervous system. Homeostasis is regulated by copper. Regulation of gene expression, brain development, pigmentation, immune function also mediates in by copper. Okay, so copper is used in one form. Excessive usage of copper is a deadly, and that's why this copper is used in insecticides, fungicidal and algacidal. So usually this greenish slime, algal slime can be removed with the help of copper induced fluids. Okay, so environmental exposure to copper exposure. So environmental copper exposure that include copper water pipes. By using copper water pipes, cookware, all these copper mediated metals can induce this copper toxicity in a nutshell. Okay. And occupational exposure. So plumbers, welders, mechanics, and other people who are working with copper are highly prone to copper toxicity. And dental applications. So some certain dental appliances also have this copper. Okay. So copper is used in dental alloys, in filling crowns and other appliances. So poison components of copper. See, copper in the form of subacetate and copper sulfate. Okay, copper sulfate is the most common form of toxic form of this copper. Okay, so this copper sulfate is also called blue vitriol. So blue vitriol is a common name for this copper sulfate, and it will cause many toxic effects. So this is all about copper. So signs and symptoms of copper poisoning. Very important thing, either radiation exposure, okay, like a nuclear radiation exposure or this heavy metal exposure, the patients will start experiencing some metallic taste on their tongue. Even though they are not eating anything, but still they will experience this metallic taste. So experience of metallic taste is a sign of heavy metal poisoning. Okay, heavy metal poisoning occurs because of this uh, okay, metallic taste. Metallic taste is one important sign and symptom. It's an indicator for heavy metal poisoning. And also in copper poisoning, we can see increased salivation, burning pain in the stomach, nausea, vomiting, general GIT abnormalities, diarrhea, and even in severe cases, some patients may even experience hemolysis, jaundice, pancreatitis, convulsions, and spasms of lungs. Okay, so breathing difficulty, cold perception, and severe headache can happen. So, and even liver and renal failure can be observed. Okay, so these are the some sciences in terms of copper. I know this is boring. I'm just moving ahead. Okay. So fatal period, if you are exposed to copper for 1 to 3 days, that's it, game over. Okay. And in the lethal exposure to this copper, the skin will turn to greenish blue color. Okay. Greenish blue discoloration of skin indicates a copper toxicity. Okay. So fatal dose of copper is greater than 30 grams. Okay. In case of copper sulfate, whereas in case of copper subacetate, it is 15 grams. Okay, so all these are boring normal values you need to memorize. Then coming to the laboratory diagnosis. So in the lab diagnosis, we can the ideal sample will be serum. So in the serum, we need to identify the levels of copper, or the blood copper level greater than 1.5 micrograms indicates per 100 ml of blood, like indicates likelihood of serious toxicity. And ammonium hydroxide is a another form of copper. Okay, copper will embed itself into biomolecules, our biological molecules, and that will be in different forms, like copper ammonium hydroxide. So copper itself will establish into the ammonium structure, and it will cause certain health issues. And also hair analysis. So copper can also be shed in the hair tips. So even hair sample can be used for identification of copper toxicity. And usually students, these heavy metals will be extensively studied in forensic laboratories. So if you are going for, if you're gonna work in any forensic medical laboratory, okay, forensic lab, their primary target is always this heavy metals only, because most of the cases unknown deaths is due to poisoning only. Okay, so that is why the first priority they will give is whether the patient died because of any toxin. Is there presence of any trace elements, is there any heavy metals within the dead body or not. Okay, so identifying these heavy metals in the body gives a very important clue of uh, exposure to poisons, any type of poisons. So if you, any one of you who are interested to go to forensic lab, to work in forensic lab, then better keep an eye on this subject. Okay, this heavy metals lab diagnosis, because this will be the primary area in forensic biology. Okay, so they will study all these toxins. It's really interesting. So I went to this no, forensic lab in Chennai. Okay, it's really nice experience. So they bring these steel buckets, they kept on a table, and they kept their hand and they removed one head. So they kept a head on a table, and we started seeing the, they are studying, they're reconstructing the face by this skull. So they are trying to study the decay of head, and now they are trying to reverse engineer the decayed body to a healthy, a normal head. So they are using some software, and they're doing, it's really interesting experience. Anyway, so that is all about this copper. Okay. I think actually today is first day of induction students, the offline students. So that's why there are many people getting some distractions. Okay. So this is all about this one. Then treating. So any heavy metals can be treated by this chelation methods. Okay. We will give certain drugs, and these drugs will neutralize the toxic effects of these heavy metals. Okay. So this is how we can able to treat the patients. Okay. So here we are using potassium ferrocyanate. So potassium ferrocyanate will neutralize the toxic effects of copper in the body. Okay. So albinate of copper. Okay. Potassium ferrocyanate will convert to albinate, and it will neutralize it. And chelation can also be achieved with the help of penicillamine, EDT, or VAL. I don't know the full form of VAL, but by using penicillamine or EDT also, we can able to neutralize the toxic effects of copper. So this is all about copper. So yeah. Then next metal, next heavy metal toxicity is iron. Okay, so we will discuss about iron now. So iron toxicity. Now, before discussing about iron, I want to tell that iron plays a vital role in keeping in body's metabolism. Okay, because iron is the key ingredient in the hemoglobin. So this hemoglobin structure has this iron molecules. Okay, central copper atom, and this copper atom has been binded with 4 iron molecules. These iron atoms will capture the oxygen. Okay, so now the major problem with iron is our body has a extensive mechanism of maintaining, it is trying to tolerate with iron toxicity. Actually, iron is very dangerous product, but still we need this iron for our regular metabolism. So it is like this, keeping a toxin in your throat and not trying to engulf it. So maintaining a toxin in the throat is very tough, right? Like Lord Shiva kept that some poison in his throat. I hope you know this story. So similarly, our body is, it's struggling a lot to maintain this iron hemostasis in the body. If some disbalance occurs in this iron hemostasis, that's it, or multi-organ failure will occur. Okay. The problem is iron has a tendency to deposit easily in the body tissues. Okay. It is very tough to remove iron from body because it requires a lot of energy to remove iron from the body. Okay. And energy is conserved. So energy is ATPs we need for other metabolisms, other things. So just directing ATPs just to excrete iron is not an ideal approach. So yes, our body struggles a lot to maintain these iron levels. Excessive iron, game over. Low iron, game over. So maintaining that optimum is the toughest challenge that our body is undergoing. In fact, 3% of genome, the 3% of human genome is dedicated to regulate the iron in the body. So now you can understand, right? So almost one chromosome, okay, half of the chromosome is dedicated for iron monitoring in the body. That's a big deal. Okay, chromosome means it has thousands and lakhs of genes, and they're all regulating just for iron metabolism. Yeah. So let us see this iron and what are its effects. So iron poisoning. See, as I stated, we require iron in our regular diet, but excessive iron can kill us. So usually pregnant women need these iron tablets, right? But the same pregnant woman can prone to iron toxicity, and they may eventually die because of their iron supplementation. So it's like a double-edged sword. Either whatever end you are catching, there is some risk. Okay, so iron supplementation is really a risky treatment to any patients. Uh, Without analyzing body mass index, without seeing the patient BMI, blindly giving iron tablets is a dangerous thing. Okay, so I'm telling again, iron looks like a friendly atom since our body demands iron a lot, but still iron is a dangerous thing. Okay, so what are the health benefits of iron? So it treats anemia, it boosts hemoglobin, it reduces fatigue, it boosts immunity, it improves concentration, and it even restores sleep. Simply, students, iron, without iron we won't have blood. Without blood we won't have oxygen. Without oxygen we will die instantaneously. So everything is interconnected. Okay. So we need oxygen. For that we need hemoglobin. For that we need blood. And in the blood we have iron, and iron plays a major role indirectly. Okay. So these are the health benefits of iron. Then what are the side effects of iron toxicity? So iron overload can cause all system problems. It will cause constipation, it will cause nausea, indigestion, stomach cramps, diarrhea, black tarry stools. Okay, so presence of blackish stools is an indication of iron toxicity in GI tract. Okay, so if you underwent any iron toxicity, there is a chance of getting black color stool. That is one important symptom and sign of iron toxicity. Apart from it, iron will also cause a toxic effects on pituitary gland, thyroid, heart, liver, adrenal, pancreas, ovaries, testes. That means even iron intoxication will make us sterile. We will become sterile that we cannot get children, so it can cause this sterility also. So you need to be cautious with iron supplementation. Okay, so physical appearance, iron is a metallic, we already know how iron looks like, but the most common form of iron will be ferrous sulfate. Okay, so this green color thing is called ferrous sulfate, and it is this form of iron that will cause more health issues. So the common health issues are associated with ferrous sulfate form of iron. Okay, so ferrous sulfate will cause more health issues in the body. Then naturally in outside, the iron present either in hematite form or in magnetite form. Hematite is surface iron deposits, whereas magnetite is subsurface iron deposit. So under the ground, iron is present in the form of magnetite, whereas on the surface, iron present in the form of hematite. So this is a dirty iron. It need to be enriched to get a pure iron. Anyway, these two won't cause any health issues because they are insoluble. But the soluble form, which is the ferrous sulfate, is the very dangerous to the body. So it is because of this ferrous sulfate we will get all iron mediated toxic effects. Okay, so this is one best identification. So this is called hemochromatosis. In the patient who has exposed to this iron toxicity, their skin will have this characteristic brownish tint. Okay, this brownish discoloration happen because of this iron toxicity. So this is one sign for iron toxicity. Okay. So what is the daily intake? So daily intake will be 10 to 20 milligrams for adults, whereas increased iron supplementation required in case of pregnancy, because mother also bearing another small fetus. So fetus should get iron. So that's why up to 30 milligrams mg in mothers pregnant women is common. Okay, whereas average daily intake of adult will be around 15 milligrams. Okay, mg. So this is the dietary source of iron. Then environmental sources. So iron present in the earth crust, we need not to worry. We are not going to eat original iron. Okay, like the iron present in our railway track. We are only discussing about ferrous sulfate form of iron. So what are the sources of iron? So the sources of iron include all your beans. Okay, all beans and leafy vegetables have a very good iron. Okay, and also iron present in citrus fruits, lemon, orange, mosami. All these citrus fruits have iron. Okay, so iron is present in citrus fruits also. And if you are a non-veg, then iron present in pork, chicken, liver, beef, everywhere. Okay, even this shrinks and egg yolk also. This is France. Okay, so these are the few food sources where we will get iron supplementation. Broccoli. Okay, broccoli will do so much health and health benefits. broccoli and even watermelon has so much iron. So kindly mind this food and try to take it regularly. Okay. So yeah. So we are not going to discuss about industrial uses of iron. So I'm just skipping this one. Then biological uses. I need not to discuss much. We already know what is the biological uses of iron. Iron important in hemoglobin synthesis. Because of this hemoglobin only we are surviving. Because of this hemoglobin we are getting oxygen. So there is nothing much to elevate this one. Then let us see pathophysiology or the physiology of this iron. So iron will be ingested in the form of ferrous form, okay, F3 plus form. So this F3 plus form will enter into the stomach. Okay, so here it will be converted to Fe2 plus to again iron form. Then it will be absorbed. Now there is a chance of this absorbed iron will be deposited in the liver. Then it will be deposited in the liver. It will be converted to ferritin. Okay, it will be converted to a biologically okay, it will be converted to a form that is essential to embed it in the hemoglobin. So it will convert its structure where it can able to place its structure into the hemoglobin molecule. Okay. So I'm not going to tell these fancy names like ferritin, apoferritin, etc. So in the process of this conversion, there is a high chance of deposition of Fe3 plus, the bad form of this iron in the tissues. And also when we are saying hemoglobin, hemoglobin not only present in red blood cells, but hemoglobin also have a secondary form called myoglobin. This myoglobin will present in the tissues, in the muscles. So muscles also demands huge oxygen. Muscle requires so much oxygen for their activities. Okay, so that is why even all muscles have this myocytes, and myocytes have this one form of hemoglobin. Okay, that means iron present in muscles also. That's why people who are going to gym, they will say that I need iron pump. They will eat this all iron supplementations. So maybe you're eating iron pump, okay, but excessive pump will, it will tear you. So you need to be cautious when you're taking this iron supplementation. Yeah. So the same story in a much technical way they discussed here. So how iron entered into the body, what is the form of apoferritin, how it is stored, how it is transferred, how it is metabolized in the body. So those things has been discussed in much elaborated way. You need not to worry about this one. Okay, we are not going to study biochemistry here. We are just seeing the toxic effects. That's it. So somehow in the process of this, the iron will be deposited in the tissues and it will cause some problems. Okay, that you need to know. Then fatal doses. So iron in a single day, if you are getting exposed greater than 150 mg of tablet, that's it. You will be prone to iron toxication. Okay, so now this iron poisoning has been categorized into 5 stages. Okay, in one day you will die, or in 1 week we will die. If we are taking excessive iron, in 1 day we will become very weak, whereas in 1 week we will die. So let us see this whole stages of iron. So within first 6 hours, okay, within first half an hour we can say, within first half an hour we will get gastrointestinal problems. See, within half an hour of iron toxication we will get a stomach problem. Okay, but then within 2 to 4 hours, okay, within 2 hours you will get latent phase. Then for 4 hours, shock, multi-organ failure. Within half day you will get liver toxicity, and within a week you will die because of gastrointestinal obstruction. So let me show you all these 6 stages in much detailed way. So stage 1, this happens within 2 hours. It will cause hematosis. That means a blood iron toxicosis. Then abdominal pain, diarrhea, shock, and coagulopathy. Whereas in stage 2, false sense of security. So here, our immune system will start dysfunctioning. Okay, immune dysfunctions can be observed here. Then stage 3. In stage 3, you will see shock, acidosis, cyanosis, fever, hypotension, CNS, depression, central nervous system depression. Then in the stage 4, within a day, you will get hepatotoxicity, liver damage, convulsions, coma, and acute lung injury can happen. And in the stage 5, game over. Okay, we can say goodbye to patient. That means there is a likelihood of death. There will be this GI scarring, strictures, and GI obstruction can be seen in a week of severe iron toxicity or chronic iron toxicity. Okay, so diagnosis is very, very important in iron toxicity. So the diagnosis is testing serum iron concentration is the best method to confirm iron poisoning. So repeat the serum test for 4 to 6 hours after intestinal measurement. What is the reason means in order to assess the stage of this iron toxicity. Maybe by the time of we are seeing, maybe he is in only first stage. That is why his iron may not enter into the stomach. In order to assess the lethality of the iron toxicity, we must take periodic samples from the patient. Okay, to measure the level, the quantity of iron he has been exposed. Okay, that is one reason. Then total iron binding capacity is one more important test to assess the iron toxicity, so toxic effects in the body. Then an abdominal radiographic examination can be done. So abdominal radiographic examination is very simple. We will take an X-ray of the patient and we will see whether we can see any iron deposits in the body or not. So I will show you that iron X-ray. So here, see. So this is a patient who has taken this iron supplementation. So we can clearly see the iron tablets has been accumulated in the stomach. That means this patient's stomach have not metabolized and have not digested the iron tablets. So this is one problem. Then chelation challenge test. Chelation challenge test is also an important test to see this one. So here what we will do is we will give a chelating product which is desferroxamine. So desferroxamine, okay, desferroxamine is a tablet that can able to neutralize the iron toxicity. We have a very good strategies to recover the patient who have this iron intoxication. So we have very good strategies. Okay, and one among the drug is desferroxamine is an ideal drug for neutralizing the iron toxicity. Okay, this is another interesting test. So the patient who is under this desferroxamine, the patient who has this iron toxicity, their urine will be in rose color, pink color urine. Okay, so if our drugs are working, then eventually his blood will become, it should become clear. So now I will show. That is, this phenomenon is called a Windrose color in urine. Okay, Windrose phenomenon. So Windrose means, so this is the iron intoxicated patient's urine. So after giving desferroxamine tablet to this patient, slowly he is recovering from iron intoxication. See, at one time his urine became clear of all iron. So recovery of iron can be seen under desferroxamine therapy by a urine test. Okay, periodic urine physical examination is important to see this iron toxicity in the patient, and this is called Windrose phenomenon. Okay, so this is another important test for iron toxicity. Then treatment. There are multiple approaches to treat the iron toxic patients. Okay, chelation therapy, we have desferroxamine as I stated. This therapy is there. Then even we can give saline buffer. Okay, saline can be ingested into the stomach and we can wash the stomach. Okay, saline wash can be done. And also electrolyte therapy can be given. Electrolyte therapy means this saline only. Okay, saline therapy given to remove the toxic effects of iron in the patient. Okay, so for what patients we need to perform this chelation therapy. So this chelation therapy should be performed in the patients, okay, who has any clinical signs of shock, lethargy, coma, altered mental status, persistence, vomiting, diarrhea, hematitis, or hematochia. So hematochia means it is the brownish rashes on skin. Okay, because of iron toxicity, the iron will be deposited in the tissue, in the skin, and it will have brownish patches. So that is called hematochia. Then a positive anion gap metabolic acidosis, large number of piles on. Okay, the patients who are undergoing this radiograph, we will purposefully give more iron. So this iron will visualize the body brighter under the X-ray. So in some certain radiographic examinations, we will purposefully induce more heavy metals into the patient body in order to visualize. So in that cases, we need to immediately keep the patient in chelation therapy. We given more quantity, we took X-ray, then immediately we should keep in chemotherapy. Okay. Then iron levels are greater than 500 micrograms per deciliter is an indication for taking the patient in chelation therapy for iron. Okay. So same story. So preservation is better than cure. So that is why the patients who got this iron toxication, they should be in regular checkups. Phlebotomy should be done. Phlebotomy is very important We need to take frequent blood samples and we need to analyze the levels of iron frequently in the patient. Then food. Okay, the suspected iron toxicated patients should not should not depend on heavy diet, such as the diet that has this iron rich things. Okay, yeah. So then iron pills, they should not take iron pills. They should not take vitamin C, because vitamin C increases the amount of iron. Okay, vitamin C is very good iron absorber. Okay, that is why in to pregnant women, we will recommend the pregnant women to eat this citrus fruits, this citrusin components, because citrusin components will enhances it. They will increase the iron absorption in the body. So that is the primary reason. And also exercise. Okay, so if you are doing more exercise, there will be more muscle wear and tear. Because of muscle wear and tear, there will be more iron metabolism, metabolic pathway, and that can induce secondary side effects in the body. So these are certain um, preventive measures that you need to take. Okay. So yeah, phlebotomy means collection of blood. Collection of blood is called phlebotomy. Okay. So yeah, phlebos means blood vessel. Ectomy means to cut. So cutting simply collection of blood is called phlebotomy. Okay. Yeah. Yeah. Actually, I have last time I took an entire subject on phlebotomy. So there are many challenges in collecting blood. Okay, many challenges, and there are many complications. Just induce one air bubble in the blood vessel. That's it. The patient will die within 2 minutes. So collecting blood need to be very careful. If you induce air into the patient's blood, that's it. It will be really challenging. Okay, it will cause embolism. It will cause ischemic heart attack, or it can even block the blood going to the brain. So the performing or collection of blood is really a sensitive and most important thing that we need to do. Anyway, so a quick revision of today's lecture. So in today's lecture, we discussed in detail about copper toxicity and iron toxicity. Okay, so copper toxicity, as I stated, copper is also has many good health benefits. Okay, the main symptom of copper toxicity is presence of this Kaiser-Fleischner rings, this brown color rings among the eyes. Okay, so this is all about copper. Then we discussed about iron. So iron is very important, but excessive iron intake can cause iron toxicity. Okay, so this is called this one form of iron toxicity is called hemochromatosis. Hemochromatosis is a excessive iron toxicated disorder. So thank you very much, students. This is all about iron. In the next tomorrow, I will conduct exam on first 5 heavy metals. On five heavy metals, I will keep a quiz exam. Everyone must attempt it. Okay. So I won't. I will be very serious, because whatever marks you are getting, that will be considered for your final exam. It will be added in your final DMC. Okay, mark sheet. So be serious. Tomorrow I will conduct exam. Okay. So thank you very much, students. Thank you very much. I'm ending this session.